morning, students. Today we are going to use again the course digital signal processing. In that we are going to study about the session 3 about the realization of a filter. So here we are going to use the realization of IR filter. So remaining part of this IR filter realization, that is a cascade form and the parallel form realization. So this is the cascade connection. Cascade means cascade H1Z, H2Z sequentially in serial manner. We are going to connect the transfer functions H1Z, H2Z up to the HLZ. There is a single input X of n and the output is a Y of n. Then overall transfer function, how we can write, this is the H1Z into H2Z up to the HLZ. Each one of them can be implemented using any of the one direct form format. Any direct form 1, generally we are going to prefer direct form 2 because we require the less hardware for that purpose. So this is the cascade connection again, H1Z multiplied with the H2Z, H3Z, Y of n is the output. Cascade connection, here one example is mentioned, here we are using the X of n. Okay, so here we are using the X of n and here we are using the output is Y of n, and then the whole equation is cascaded together. Here we can say that this is the H1Z and this we are calling as a H2Z, and likewise we are cascaded two transfer functions and you will get the output. So we can use any, here when you observe this diagram we found that there is a direct form 2 concept is used for the realization of cascade connection. So only thing is that how we can make the cascade connection. One example we are going to focus, then you can get more clear about what is the cascade connection realization. Second part is a parallel realization. In the parallel realization, here is the input is X of n, output here we are going to see is the Y of n is output. So parallel connection we require the summation or the adder. We are using the adder H1Z, H2Z, H3Z. Likewise, here because of that the equation is H1Z plus H2Z plus H3Z up to the last HNZ. That is our final equation of the parallel realization. Means parallelly all the transfer functions are realized H1Z, H2Z up to HNZ, and then we require adder for every realization, and then we are getting the final output by using the parallel realization. Now, this is a parallel IR structure we are using. This is one example. Suppose for example, it is a one constant term here. H of z is a some constant term is used in the first part. Summation L varies from 1 to n, P of L 1 minus lambda L z raised to minus 1. This is we are using some term, and or in second order term we after that we are using this one. So when you observe overall one constant term z raised to minus 1 and z raised to minus 2. So here we require z raised to minus 2 means what? The two delays are there, mu naught, mu 1, these are the in the numerator values, these are some constant multiplier. Alpha 1, alpha 2 is the another constant multiplier that we are using for the realization. So just observe this parallel form structure. So this is the first part. When you observe the equation, this is one part, that is a mu naught separately plus added with, here it is the summation is used. So we can use one numerator separately and one upon denominator separately, or we can realize by using the direct form 2. Just observe this, minus alpha 1 minus alpha 2 alpha 11. So mu naught means this is the x, mu naught is connected, y is the output. Another is for alpha 1, this one, and mu naught, mu 0 1, mu 1 1 up to that, then mu 0 2, mu 1 2 up to that, means variation. So some terms become parallel path, means it's a general structure. From the problem solving you will get more details about how we can make the parallel realization. There is a one trick for the parallel realization. If there are different factors are there in the denominator, we need to factorize it, find out the what you can say that find out the constant value ABC, and then we are going to realize how it is, that we'll see. This is the one example. Obtain the cascade form realization of a digital system. This is the equation is given, y of n 3 by 4, y of n minus 1 minus 1 upon 8, y of n minus 2 plus 1 upon 3, x of n minus 1 plus x of n. Given equation, taking z transform of above equation, we get y of n, z transform of that is yz, 3 upon 4, y of n minus 1 means z minus 1 multiplied to the yz, y of n minus 2 means z minus 2 multiplied to the yz, n minus again 1 here, z minus 1 is multiplied with the plus 1 upon 3 and xn is x of z. Now, we are club x, yz and xz term together. So, we are going to club this one yz term, xz term together, find out the transfer function. So, transfer function yz and xz, yz upon xz, 1 plus 1 upon 3, this is our transfer function z raised to minus 1. So, when you observe this, the numerator and the denominator multiply h of z either z square or how we can realize this, observe this. In the individual transfer function we can use by using the direct form 1 or direct form 2 and connected in cascade. So, this is first problem we are going to consider for the cascade realization. Cascade realization generalized equation is h1z multiplied with the h2z multiplied with the h3z, that is our overall h of z we are going to estimate. Separate realization we are using. Now, observe this h of z 1 plus 1 upon 3, this is equation what we used here. Just observe this once again 1 plus 1 upon 3 z minus 1. We are making the factorization of this denominator parameter, right? Because of that, in this equation after the factorization 1 minus 0.5 z minus 1, 1 minus 0.5, then 25 z minus 1. So, these are two factors are estimated for the denominator. Second order equation is there, we are getting the two factors and we are having a choice convert into h1z and h2z. How it is? Hz is the overall equation. Either you can select the first para for the h1z and second one is h2z or vice versa, right? Or vice versa, or 1 plus 1 upon 3 z minus 1 upon 1 minus 0.25 z raised to minus 1, that also we can consider as a h2z. It is our choice, for our convenience we are going to select h1z and h2z. So, there are two h1z and h2z we are getting. Now, our main focus about the realization. This is the realization, we are using the realization here. So, when you observe this equation 1 plus 1 upon 3 z minus 1, here single delay for h1z, single delay for the denominator also, multiplication 1 upon 3 and this is the 0.5. So, when you observe this 1 upon 3 and minus a1, that is a plus 0.5. If it is a minus 0.5, it become plus 0.5. If it is a plus 0.5, this multiplier become the minus 0.5. This is the direct form 2 realization we are using for h1z. h2z, when you observe the h2z, just observe it is a 1 minus 0.5 z raised to minus 1. So, only left side values are there, minus 0.25, here it becomes plus 0.25, right? Left side, when denominator at the left side and numerator at the right side. Be carefully, there is no numerator value, because of that multiplied here 1. So, this is the cascade realization. We are directly cascaded together these two terms h1z and h2z, because it is a multiplier. So, likewise by using the direct form 2, I realize this cascade, this problem by using a cascade realization. Just observe this final diagram for the cascade realization is like this. Okay. Now, we are going to focus for the one problem on the parallel realization. Obtain the parallel realization for the system. So, this is the equation is mentioned h1z final realization here. Here what we will have to do? 1 plus 1 half z raised to minus 1, 1 minus 1 upon 4 z raised to minus 1. These are the three factors in the denominator, okay, and two factors in the numerator. And what is our ultimate goal in the parallel realization? hz is equal to h1z plus h2z plus h3z, means it is a addition. Now, when you observe this, the important thing is that there are three factors in the denominator. Find out A, B, C, factorize by using a partial fraction expansion method. Okay, study, this is a reference point. You will have to solve this problem by own, find out A, B, C values, factors, and then we are directly use the ABC value for the realization. Just observe this, I did the calculation, h of z is equal to a equal to 8, this is the a value, this is the b value and this is the c value, a equal to 8 upon 3, b equal to 10 and c equal to minus 35 by 3. There are 3 factors are there in the denominator. Direct equation h of z, we are going to simplify this for the parallel realization h1z, h2z and h3z. Now, realize this by using the parallel realization. Y of n is the output, x of n is the input. When you observe the previous, 8 by 3 is the multiplier for the numerator and 1 plus 1 half z raised to minus 1. First h1z, how it is realized? 1 plus 1 half plus become minus 1 half. This is the direct form 2 realization. So, remember this is important. Every cascade realization as well as parallel realization, make the practice to realize by using a direct form 2. Okay. So, again I repeat, in the direct form 2, numerator to the right hand side, denominator to the left hand side, multiplier are making the sign of multiplier reverse. If it is a plus 1 half, so make it minus 1 half, which multiplier we are using in the denominator. So, here in this equation, the first part, it is a, what is the first part? 8 upon 3 divided by 1 minus plus 1 half z raised to minus 1. So, plus 1 half, it become minus 1 half. What is this equation? 10 upon, just observe this equation. What is the equation? 10 upon 1 minus 1 upon 4 z raised to minus 1. What should be the result? 10 is the multiplier for the numerator. So, left side, instead of minus 1 by 4, it becomes plus 1 by 4. So, this is becomes plus 1 by 4, single z raised to minus 1. Another multiplier for the numerator, minus 35 by 3. Here denominator, so 1 upon 1 minus 1 plus 1 upon 8 z raised to minus 1. So, 1 plus 1 upon 8 z raised to minus 1. Likewise, the parallel realization, final important point is this plus sign. We are making the adder. Either we can use the separate adder here, or 2 added then add with the third one, or you can use the single adder, and that is we are calling as a summation of all the result, and then you are getting the final output y of n. So, students, today we studied about the IR filter realization by using the cascade realization and the parallel realization. Problem solving on that, I think everybody understood well. Practice again for the different problems, you can enjoy the realization of IR filter. Thank you very much.